How do you handle your MCMC samples once your Bayesian model fit properly? Which diagnostics do you check to see if there was a computational problem? And isn't that nice when you have beautiful and reliable plots to complement your analysis and better understand your model? I know what you're thinking. Plotting can be long and complicated in these cases. Well, not with ArviZ, a platform-agnostic package to do exploratory analysis of your Bayesian models. And in this episode, Ari Hartikainen will tell you why. Ari is a data scientist in geophysics and a researcher at the Department of Civil Engineering of Aalto University in Finland. He mainly works on geophysics, Bayesian statistics, and visualization. Ari is also a prolific open-source contributor, as he is a core developer of the popular Stan and ArviZ libraries. He'll tell us how PyStan interacts with ArviZ, what he thinks ArviZ's most useful features are, and which common difficulties he encounters with his models and data. This is Learning Bayesian Statistics, episode 10, recorded January 21, 2020. Welcome to Learning Bayesian Statistics, a fortnightly podcast on Bayesian inference, the methods, the project, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country, and reach a true Bayesian state of mind by visiting learnbayesstats.anvil.app. That's learnbayesstats.anvil.app.
Let me show you how to be a good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. What's a Bayesian? It's someone who cares about evidence and doesn't jump to assumptions based on intuitions and prejudice. A Bayesian makes predictions on the best available info and adjusts the probability, cause every belief is provisional. And when I kick a flow, mostly I'm watching eyes widen, maybe cause my life...
Ari Hartikainen, it's a pleasure to have you on the show. I'm glad to have another guest from the Stan ecosystem. I had Michael Betancourt on the show the other day, and this episode was particularly appreciated by listeners. I thought it would be interesting to have you on the show because, well, you're working on Stan, but you're also working on another library that we talked about on this show before with Colin Carroll. But it was not the main topic. Here we'll be able to dive a little bit more into ArviZ's guts, because the library is ArviZ. But before that, I think it would be good to start by some definitions, because I think you're the first geophysicist to be on the show. So quite simply, what is geophysics?
Yeah, so geophysics is we kind of study what's underground. We usually want to know something what's like underground, like maybe in 1 kilometer down. There is like no way to get there. So we use some physical methods, like we use seismic noise. We try to infer from those soundings kind of what's under the ground. And we use different physical methods like electromagnetic radiation. That's the one way to infer what can we see somewhere where we cannot really see any other way. It's a study of Earth in kind of like...
Okay, it's like you're a physicist, but studying what's going on underground.
Yeah. Then there is like two different kinds of geophysicists. There are people who study how the mantle and how the core of the Earth works. But I'm actually studying how the near surface, like few meters to few kilometers, how that area is working. So.
Okay. It's funny because the other day I had Maggie Liu on the show, and she's a cosmologist. So basically we had the point of view of someone who is studying what's going on above the Earth. And now, thanks to you, we've got someone studying what's going on below the Earth. So thank you for that. Actually, is geophysics like contained to the study of what's going on underground the Earth? Or would you be able to also do geophysics on Mars, for instance? If the European Space Agency goes to Mars with a probe and comes back with some samples from Mars, would geophysicists then be able to study these samples, or is it something totally different?
Yeah, I mean, studying sample is really close to the geophysics. It's kind of like a part of geology and petrology. So those are studying the minerals and rocks. So we put the probe on the Mars and we would study how Mars is vibrating. And that is currently actually doing that. I think it is NASA or something is doing that on Mars
Okay.
now.
So it's not specific to Earth study. You could
No,
do that on other planets. Okay, that's good for you because if you have to leave Earth one of these days, you will be able to continue working there.
Yeah, that sounds good.
Although that sounds like kind of a black swan, so I doubt that you chose geophysics to do exactly that. So I'm curious, what got you into geophysics?
I have always really liked to study rocks and study minerals. And in the formal sense, I'm actually doing geophysics and technical geology. So basically geology with some data science on it. So somehow I just want to work on different rocks or maybe soil. So that's something I have always wanted to do. And that's how I kind of went and studied.
Oh yeah, that's awesome. Not a lot of people are able to do that. Figuring out what you want to do later when you're an adult, it's it's kind of hard. So I think it's easier to talk about your background now, because also from what I understood, you started by civil engineering, right?
Yeah, so civil engineering is like what we do when we're building roads, building houses. A lot of those things when we are studying how to build those, we need to know a lot of information about what's underground. So that's like geophysics are a really good fit into that civil engineering genre. So if you think about any tunnels, you have to know what kind of rock you are going to have if you are going to build a tunnel, especially when we have the geology in Finland is a bit different than in geology in rest of the world, because we have only like these kind of really old hard rocks, but rest of the world has these kind of like sandstones and sedimentary rocks. So in Finland, we are kind of like in a special place.
I didn't know that. Do you actually know why? Is Finland that special on this front?
It's about how Earth has evolved. So basically it's random why it's in Finland, but we have locations that have really old rocks. So we have a Finland here, and then some parts of Australia has really old ones, and also Canada has some parts. So it's a bit luck that we in Finland we have this kind of geology, and part of reason is also that because we are so northern, so we have had these ice ages that are scraping down all the sedimentary rocks. There is like 20 or 40 kilometers of rocks has gone away from this location where I'm currently sitting. The rocks that we are having on the surface now are basically the same rocks that are underground under Himalaya, somewhere in minus 50 kilometers or something. So
that's fascinating. I didn't know that. And it's really specific to Finland. I mean, you can't find that in neighboring countries like Norway or Sweden.
Northern parts have the similar rock types, but especially Norway is basically a mountain, this kind of mountain ridge, and it has a lot of these sedimentary rocks that has come from the seafloor. And parts of Russia is also having this kind of really old rocks.
Yeah, that makes sense, knowing the geography of this area. Okay, well, thanks for that. It was very interesting. I didn't know that. So what do you do today? Because we talked about your studies, your background, and what you're doing today. I'm guessing you're working in geophysics still?
Yeah, I'm doing a lot of data science, and this data science is kind of like coupled with the geophysics and geology. I'm also doing a PhD on civil engineering about using these ground-penetrating radars and how the radiomagnetic signals behave underground. What's the accuracy that we can measure underground and these kind of things. GPR is like something that less than 10 meters from the surface, and we are studying like that part of what we can see through the road surface and see different layers there. And then I do also some spatial stuff, so like trying to understand how rock surface or some surface underground behaves and what kind of like knowledge we can gather from measurements and how we can use mathematics to describe that.
Okay, that sounds really interesting. So you're doing your PhD while you're also working?
Yeah. Currently working on a private sector, but I'm still doing my PhD. And actually the private sector firm that I'm working has really tight connections to the university. So that's a good thing.
Oh yeah, it must help you combine both projects and both incentives. I would guess that for most people it's quite hard to combine professional experience like in industry and also another professional experience, but in academia through the PhD.
Yeah. And also I have a possibility to work with researchers from university and also working with the engineers that we have in our firm. So it's an interesting mix.
Yeah, definitely. It sounds like so. Yeah, you're kind of like at the middle of academia and industry where borders are quite gray. And so you can work on both at the same time. It's great. You also do a lot of open source contributions. As I mentioned in the introduction, you're a core developer of Stan and ArviZ. And so I'm curious, how did you end up doing that? How did you end up working on Bayesian statistics and open source development while coming from a geophysics and civil engineering background?
That's quite interesting. I really started to code after I did my master's. So I did my master's on using R, but then I decided to change to the Python.
During your master's or?
After my master's.
After, okay.
I before my thesis, I used a lot of MATLAB. I did some statistical work for my thesis. So I did all of that thing on R. I had learned Python before that, but then I decided I want to be a bit better or really good at Python. So I started to do that. It took me maybe a few years before I even started thinking about contributing to open source. I have to say that I should have started a bit earlier. You don't need to be a superstar or anything like that to contribute because, just having a discussion is enough. You don't even have to code. You can discuss different things and that's really helpful because usually you are alone thinking about what to do and having somebody to discuss the problem is usually much easier to solve it. I did a lot of this kind of Reddit helping stuff. There is Learn Python channel. So I did a lot of solving problems there. And at some point I decided I was maybe doing that, I was good. Somehow I found PyStan. Was at the same time doing this kind of a mathematics course about inversion and inverse problems. That's the main meat or main problems in geophysics is solving these inverse problems. One way to solve these problems is doing MCMC sampling and using Bayesian statistics. That's a really good way to do that because you can go to this kind of a super resolution because you know a priori a lot of things that cannot happen and can happen. So you can put that into your model, then just use MCMC to solve it. And I was in one mathematics course and we did our own metropolis Hastings algorithms and Gibbs samplers and we used that to solve these different problems. And I was having this kind of a problem also in my PhD at the time. The best way to solve that problem was to do some kind of a super resolution stuff. I decided to start to learn this Bayesian statistic and I started with the PyMC3 at the time and I did some tutorials on it and trained it. I remember that from the mathematics course that the best way to do a lot of these hard mathematics problems is to be really explicit about the shapes and how do you really handle the different situations and being explicit about that. And then somehow I ran to the Stan community and read something about that. At that point I was doing half and half like a PyMC3 and PyStan, but then I bought a new phone which had Android on it. And then I want to try to install PyStan on my Android. And I noticed that I couldn't do it because there was a bug in the code. I decided to fix it doing my first PR and doing that. And I get my phone to compile my models. That was quite funny. It's still a toy example, but maybe in a few years the mobile phones are good enough to do some basic stuff. And I was starting to read about PyStan GitHub page and commenting on the issues and noticed that a lot of the issues are something that I can actually solve by just reading the source code. And that's usually how I try to learn how to use a library, is to read the source code, because usually the programmer is doing a lot of these approximations or doing something using only part of the arguments. So there is a lot of things to customize if you really want to learn something. So I read the code base a lot, and then I just noticed that I have been like commenting on the issues and trying to help on people having installation problems. At the time, the installation problems on Windows were wide, and the instructions for Windows were really hard. It was a really pain to install PyStan or Stan on Windows. I was doing that for like 1 year or something, and at the time, the main contributor or main developer for the PyStan asked, "Do you want to join the Stan community? You have been really active here, and might be a good idea to have somebody else also doing this." And I was like, yeah, maybe I should start to do this open source stuff, and that's how I started to do PyStan. After that, we have fixed the Windows installation problems. We are really strict about that. You have to use Conda. I think that's the really similar issue with the PyMC, because having these compilers to work, you have to use these Unix compilers to have a working PyStan. So having a Conda and installing is really easy on using those tools. That's PyStan part. And at the time, PyStan didn't really have any plotting. It had one function, we still have it, that was stolen from PyMC3. It was not stolen, we borrowed it. And then there was this package MCMC plotlib. That was the idea to using the same backend for plotting for PyStan and PyMC3. And that took like a year or something before we had somebody who was really thinking about doing the legwork and started to contribute. I don't remember, was it Colin or Osvaldo who started to actually work on that. That has been a really interesting project.
Yeah, we're gonna come back to ArviZ and PyStan actually in detail in a minute. I just wanted to ask 2 questions in my mind. Your journey to your open source contribution raised 2 questions in my mind. The first one is, you said that you switched mostly from R to Python during your master's, and do you remember why you did that? Or was it just by simple intellectual curiosity?
Yeah. It's interesting because I don't hate R. I just find the syntax a bit weird, but I was already doing stuff on Python before, but mathematical or statistical tools were much easier to use on R at the time. Somehow I just did my thesis with R, but the Python was always my main language, so I kind of like decided to use that one. There was a part-time I did also some Haskell, so that is totally mental language.
Yeah. Okay. And actually, how did you discover Stan? Because you started doing Bayesian stuff with PyMC3, if I understood correctly. And then you discovered Stan. How did you go about that?
When I'm doing mathematics, I really want to keep my equations and all the code really explicit about the shapes, what goes where. I remember I was seeing Stan and I was thinking that's a really good way to force you to think about what you are doing, because building your model can take some time, a really long time. When you are doing Bayesian statistics, you don't really care about how long you are building your model, because you really want to be certain that it's a good model. And then when you have done it correctly, then doing sampling is like a small part in the journey of finding the answer. Maybe it was a luck.
Yeah, but it's interesting to see that you actually wanted a tool that forced you to specify both your assumptions. But I'd say that with Bayesian inference, you're kind of forced to do that, specify your assumptions, because your priors are basically assumptions. And also you wanted a tool that forced you to specify the shapes and so on of your objects.
Yeah, because I already was quite familiar with NumPy ecosystem. I just know that doing any multidimensional work on NumPy can be really hard if you don't think about it. It can by accident drop some dimension and you don't notice it. Not the code, everything runs fine and you get some answer, but you don't notice that there have been maybe some dimension have been dropped because it was a last dimension and dimension was 1. So that's why I think it's being explicit, it's better than being implicit about the shapes.
I think it's actually one part of the Zen of Python. Explicit is better than implicit. That's interesting. And so today, do you tend to use more Stan for your models that you use in your PhD and in industry? Or do you tend to switch between PyMC and Stan depending on your use case?
Nowadays, I don't really use anything else than PyStan for my Bayesian models. But I do a lot of like these Gaussian processes. And doing Gaussian processes, usually it's much easier to use these specified libraries like GPFlow or GPY. I really like to use this George that has quite nice syntax for doing GP. So
okay, what are these tools for the listeners? Or are they like external packages that you can add to Stan?
They don't do anything with the Stan. I mean, doing Gaussian processes model kind of like this Gaussian model where you have a infinite dimensional normal function, normal multivariate, and you just evaluate it on some points. And then there is a lot of different mathematics going there. But basically, it is quite nice way to model like spatial relations with the continuous variables. They are working like the GPFlow is actually working on a TensorFlow.
Oh, okay.
And the GPY is just a Python package. You can also solve the Gaussian process stuff on PyStan and PyMC3. So
okay, that's interesting. These tools are like specifically designed for Gaussian processes use cases. I put that in the show notes because I think it will interest some listeners. And actually, I want to do an entire episode dedicated to Gaussian processes because it's also quite widespread method. But as you say, it's quite meta. So it would be interesting to have an entire episode on these because it's not that very intuitive, but it's really useful.
Yeah. I mean, it takes some time to get your head around what is going on. But once you do, I mean, it's a great tool.
And actually, I realized that I didn't ask you to tell us in a few words what is PyStan, actually. We talked about that a little with Colin Carroll in episode 3, but it would be a good reminder, I think, to listeners to just explain them what is the elevator pitch for PyStan.
Yeah, so a Stan is a probabilistic language to define some model. When you are doing a Bayesian statistics, you define some kind of model that could actually make your samples. So you measure something, you think about how those samples or measurements in, and then you model that process. Then there are some unknowns. Those are usually random variables. You use a distribution instead of a point value, like you do optimization. You find a distribution of values that could fit on those unknown variables, and then you use some language like a Stan to build your model. And then the PyStan is a wrapper for Stan done with the Python. So you can use Python to interact with the Stan language, and it's more complicated.
Yeah, but to be clear, you would define your models in Stan with the Stan language, and then you would call your model into your Python programs. But your model is still written in Stan language. You have to write it in Stan language.
Basically, it is current situation that you have to write using Stan language, which is basically really constrained language, just focusing on doing Bayesian statistics. So there is not too many things you need to actually learn before you can start to use the language.
Yeah, it's quite intuitive once you know about Bayesian inference. And I'd say that once you know how to code with PyMC3, you won't be completely lost if you start working with Stan.
Yeah. I think usually if we talk about Bayesian statistics, the hardest part is to think about that you don't try to estimate a point, that you actually use distribution and how you can handle that distribution. So I mean, that's maybe the hardest part of the mental side of the doing Bayesian statistics. Usually the language and the programs that you use, they are not the bottleneck.
Yeah, choosing the priors and thinking about generative data process behind the model is very important. And then also figuring out what's going on when you've written the model, but the model won't fit. It's the other difficult part that requires some time and experience to understand.
Good way to learn your problem. If you use the basic data science tools that you get a model and you put random forest there and just do pattern and it will tell you these are the values and you have no idea what is going on actually in your model.
Yeah, and as you say, that then the code part, that's usually difficult. Maybe we can talk now about ArviZ, because as you said, you would use PyStan or PyMC or any other tool like maybe TensorFlow or Edward or any other probabilistic programming language. Then you need to analyze your model, analyze your traces. And to do that, you use statistical diagnostics and a lot of plots. So you talked about that a little earlier, but can you tell us what the elevator pitch is for ArviZ now?
Yeah, usually we have a library to do this kind of MCMC, getting samples from some model and somehow also building the model. But when you get the samples, you still have things to do before you can be certain that the model is working as you want it to be. So you have to use diagnostic tools that can be visual, or maybe there is some theory about some function that you can use and it will tell you something. And ArviZ is basically using and trying to fill the rest of the tool chain, or at least in the Bayesian workflow, when we have a lot of different parts where the sampling is one part and ArviZ is trying to fill the diagnostic and visualization part of the workflow.
A really interesting feature of ArviZ characteristic, I would say, is you're aiming for a platform-agnostic library, right? Which means that if I run my model with Stan or PyMC or TensorFlow probability or so on, as long as I get back a chain, I can put that into ArviZ and get the same diagnostics and plots for any platform.
We are currently working mainly on Python, but we have actually lately Seth
Axon, yeah?
Yeah, doing great work on Julia part. So we have wrappers for ArviZ doing for Julia. Also, there is work on R that is done by Stan community, doing this kind of like a posterior package. I hope that in next year or this year we have a way to transform our ArviZ data structure to the posterior structure in the R system for like RStan and BRMS and different tools that they have, and also a way to transform their data to our backend. Because I mean, every time you do MCMC sampling, you are working with multidimensional data. Like I said, working with multidimensional data can be really hard. So in ArviZ, we are packing everything in this kind of like a tool called X-Array. And this X-Array is really great because it is like a pandas for multidimensional data. And anybody who has used pandas for tabular data knows it's a great tool to work with and use it. So it's kind of like this multidimensional pandas, this X-Array. So we have a great way to handle the data. And I hope in future we actually do more work so people can actually use it as a part of the tool in the middle of doing MCMC sampling and doing simulation and using the sampling data correctly.
Yeah, I have to say, it's a really awesome work that you guys are doing on this library. I have to say I use it basically every day in my modeling workflow. So thank you again, Ari, for your work. And yeah, the project you talked about having also this tool available in R is awesome. That would mean that you would be able to run your Bayesian models either on Python or R or Julia, as you said, and whatever the language or even the package inside the language that you used, you will be able to explore and plot all your chains, MCMC chains, with ArviZ.
That is the dream.
Yeah, that's really good dream. Actually, do you have some favorite features of ArviZ that you use in your modeling workflow, either for your PhD or your work in industry?
Yes, I have a couple. The first one is this inference data. It is really making it much easier to handle your posterior samples or your prior samples. So because you have a lot of multidimensional variables, and having this kind of like a one package that can handle all of your different parts of the model, it really makes it much easier to use. Then there is this interactive plotting that we implemented just last year using Bokeh. I really like that one, and that is going to be even better in this year, to having an option to select some points and seeing how they behave in different variables. That's a great thing. And because now we have this Bokeh backend, I hope we can build more tools on top of that and having a possibility to do this kind of like a dashboard. I guess those are the two main that I really like to use.
Yeah. And to be clear with listeners, I know you worked a lot on the Bokeh backend implementation, but to be clear with listeners, it would mean that instead of just having the static plots that you get with Matplotlib, when you're working in the Python ecosystem, you would be able to switch the backend and just tell to ArviZ, instead of Matplotlib, use Bokeh now. And then you would get interactive plots that you could scroll and interact with, zoom in, zoom out, and so on, instead of now just having the static plots, right?
Yes.
Yeah, that sounds awesome. And so that's why you were talking about that would allow to make some automated dashboards from your MCMC chains.
Yes. Let's say if you have a 10-dimensional data, it's really hard to think about what is a 10-dimensional space, and having a way to select points. I really want to do this kind of like having an animation to go and selecting points as time goes on. So selecting maybe based on the draw or based on the location and seeing how that behaves with the different variables. That is something I think could be really helpful, because usually when we are watching our samples, we only see the marginal view, and having a way to search or explore the multidimensional spaces, it's something we should try to do even better than we currently do.
Oh, yeah, you mean like being able to plot and see the joint posterior distribution instead of just of only the marginal posterior distributions?
Yeah, basically. In two-dimensional world, if we are not doing any dimensionality reduction stuff like using UMAP or TSNE or PCA, we are bound to use two-dimensional plots or maybe three-dimensional, but I mean, even using three-dimensional plots can be quite hard. So that's why having a way to search multiple dimensions using only 2D tools is something that we can do.
That's a really interesting goal. And actually in our ecosystem, I guess the development that you were talking about earlier, are there also the reflections about adding an interactive plotting backend?
I don't know, actually. I know that they are using this bias plot that is based on ggplot. I think that has some interactive methods also. Actually, I don't know. I should really study a bit more. What are they doing on the R side? And also, how are they doing on the Julia side?
No, sorry, I didn't want to put you on the spot. I was just curious about if the development was kind of mirrored on the R and Julia side. Yeah, I guess you can't be everywhere, so you're already doing a lot of work on the Python side. So,
I mean, we are doing discussion with our developers and these kind of like PyStan developers, because we want to have a similar principle, similar algorithms, and similar functionality on different languages. Because I mean, doing MCMC and doing Bayesian statistics is the same depending on the language. It's all. So.
Yeah, exactly. It's a really, really nice project, and congrats again on this project.
And thanks for using it.
It's really awesome. The plotting is really nice in notebooks. It's really useful both to understand your models and also to communicate about them. I encourage listeners to check it out, either on the R or Python or Julia side of stuff. Plus, I love the idea of trying to bring together the different languages of the ecosystem, because I so often hear and see people having kind of divisive speeches and reactions between R and Python, or Julia and Python, or Julia and R, and so on. I often find that kind of useless, in the sense that what counts is what you do with your programming language. In my mind, the programming language is just a tool, and what's important is what you're making with the tool. So it's really interesting to see this project trying to unite these languages and just saying, well, in the end, guys, what counts is what you're doing with your tools. We don't care about how you get your MCMC chains.
Yeah, because I know that the same thing is going on this kind of a deep learning. Do you use TensorFlow or do you use PyTorch or what package? But I mean, when you are doing Bayesian statistics, everybody are on the same boat and it's hard to do that. So we shouldn't really care what package. Should we use R or should we use Python or Julia? Because we are still trying to do the same thing.
Yeah, exactly. Just use the language you're more comfortable with and then see where you can get from there. Okay, so we talked about the project of ArviZ teams for the coming month. And do you have any news on the PyStan side? What are your projects for the future, for the year to come?
Yeah, so PyStan is actually starting to do this Stan 3. That is the next version of Stan. And that is mostly working on the backend. Backend is going to change. And for PyStan, that is going to mean that we are actually updating how the backend is working. So we have already like this kind of like a beta for HTTP Stan. So basically you can have your inference engine on a server, or maybe it currently works on a local machine, but it's basically a server that doing all the hard work. And then you have this kind of like a shim that is just sending your information to the server and taking information back from the server. So we are actually making totally new backend. I think that has a lot of things that are going to be great, like having a possibility to handle the input-output is going to be probably much easier because we have a possibility to do maybe a live plotting of your variables, having a possibility to see how your sampling is going, maybe using ArviZ, maybe in future. So that is going to change. The language that you use, there are some small changes, but a Stan language is evolving all the time. So it is not a static language. It's the backend is going to change, but users, there shouldn't be anything huge to see. I hope that we can have a backend that is so invisible that users don't even know it if they don't want to. But yeah, there is a lot of development work on Stan side, and trying to keep up with that also is really forcing me to learn new things.
Yeah, I guess because you have to mirror every new stuff that Stan is coming up in the PyStan project, or how does that work?
Yeah, I mean, basically PyStan is doing a wrapping, but the wrapping code hasn't changed over the years. I mean, the Stan language has evolved, but we usually just need to maybe fix some small bugs or maybe add some information about doing this and that in the back end. But then we have to also try to see that the new features that language has works on the platforms, and also when we call the samples or we call the functions from Stan, that they work as they should. I think this Stan 3, that is now the new engine to translate Stan language to C++, is going to be great because, I mean, there are going to be many things that are going to be much easier to do than currently.
That sounds really interesting. And plus the possibility that you talked about to run the code on a remote server, if I understood correctly, it's awesome. Would it mean that it would make MCMC sampling more quicker?
Maybe. We hope this way of having split engine, so we could in future have this engine, same engine using from R language, from Julia, and from Python, we could use the same backend engine. The packages that are talking to the server are just really lightweight. So we could have new developers working on that, because the current code for PyStan, the backend code, if you go and see it, it's a real monster. And I try not to touch it too much, because you have to be really familiar with the code, what it is doing, and how compiling C++ modules work on the fly if you do that. And so it's really interesting, but you have to do a lot of the work to be familiar with that code. So in future, I hope that people can edit and contribute much easier, or having a lower bar to contribute.
That all sounds very interesting, Ari. I see that you've got a lot on your plate for the coming month. Plus, you have your PhD and your day work. I wonder if you sleep at all to do all that.
That is an interesting question. I don't know.
Maybe just before we close up the show, I was wondering maybe if you had in mind some common difficulties that you usually encounter with your models and your data, And how do you usually solve them? That could be interesting to listeners.
There is one scene that I usually do when I do Bayesian modeling. I go really quickly to the complicated models, and then I notice that I cannot fit the models at all. So I have to really take it down and think about what to do. What's the simplest example to do and how to build your model in steps. So I think that is the quite common case, that you make a really complicated model too quickly and your data actually don't tell you anything about some parameters. So then it's really hard to fit. So that's why, building models from the simple to complicated is a nice way.
That's a really practical advice that echoes what Michael Betancourt and Junpeng Lao said on the show in episodes 6 and 7. The basic idea is start small, think hard about what process could generate your data, think hard about your priors, and then you can think about building a more complex model. Because as you said, if you start by the most complicated version, it will probably not fit. And second, it will be a lot harder to understand what MCMC samples mean.
A lot of people are doing that. Even Stan developers are doing that. So
yeah, I think it's a basic human instinct to start by the most complicated version. I don't know why. I do that too. And that's true from personal experience. This advice is completely true and really, really useful. Starting small and then getting bigger with your model. So before letting you go, you've been very generous with your time. So I'm going to ask you the last two questions I ask every guest at the end of the show. So the first one is, if you had unlimited time and resources, which problem would you try to solve?
Yeah, I was thinking about this. I don't really have one problem. We have a lot of problems on geophysics and on geology, and we're thinking about what's underground and solving those problems with Bayesian methods and having a good way to discuss those methods also and discuss the results. Users who don't use Bayesian statistics, having some way to do that would be great. I'm working already on those, but I don't have unlimited time and resources. So
yeah, I understand. Yeah, that's basically what you're trying to do with PyStan and ArviZ. And so the second question is, if you could have dinner with any great scientific mind, dead, alive, or fictional, who would it be?
Yeah, I was thinking about, if you think about the old mathematics from really long time, hundreds of years ago, they were mostly German people. I don't speak German, so I couldn't actually talk to them. It must be somebody speaking English or maybe Finnish or Swedish. So I think Osvaldo Martin is actually doing great things. So I'll have a dinner with him.
Yeah, that sounds good. Plus he lives in Argentina, so it would be a nice trip, I guess.
Yeah, that is...
Osvaldo, if you're listening, Ari would be happy to have dinner with you. Actually, it's interesting your comment about the language. I never thought about that, and I think no guest came up with that yet. But I would say, for the sake of the question, don't worry about the language in which you would communicate with the person you choose.
Yeah, I know.
Assume that you will be able to speak to them, and then you can pick whoever you want.
Yeah.
Much. It was a pleasure talking with you. Again, I'm impressed and grateful for all the open source contributions you make, be it on PyStan or ArviZ. And I'm sure I'm not the only one. I hope we inspired some listeners to try one of these amazing tools. And I hope you'll get some sleep one day, because you do a lot of stuff. And as always, I put resources in the show notes for those who want to dig deeper. Thank you again, Ari, for taking the time and being on this show.
Thanks for having me. It was great.
This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and subscribe to the show on your favorite podcatcher, and visit learnbayesstats.anvil.app for more resources based on today's topics, as well as access to more episodes that will help you reach true Bayesian state of mind. That's learnbayesstats.anvil.app. Our theme music is Good Bayesian by Baba Brinkman, feat. MC Lars and Mega Ram. Check out his awesome work at bababrinkman.com. I'm your host, Alex Endora. You can follow me on Twitter at Alex_Endora, like the country. Thanks so much for listening. You're truly a
good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.